Select the major product of the following series of reactions. So we see that our starting material here is a carboxylic acid. And then we have a series of two reactions that we are taking this carboxylic acid through. So this first step, thianil chloride, this is a good reagent for making chlorine-containing compounds. So we've encountered this previously. We have seen that thianil chloride will react with an alcohol to make an alkyl chloride. And what we're going to see here is that it can also react with a carboxylic acid and make an acid chloride. So that's SOCl2. And so that's just going to take and convert that carboxylic acid into the acid chloride. So this is a way to activate the carboxylic acid. All right, that's what we call it. So this is how chemists activate the carboxylic acid, by conversion to the more reactive carboxylic acid. So by converting it to the acid, I said more reactive carboxylic acid, I'm sorry, the more reactive acid chloride. And it's more reactive because now you've got a good leaving group, right? So when you had the carboxylic acid, this is a poor leaving group. And once you have the chloride, now you have a really good leaving group. And so your acid chlorides are the most synthetically useful of your carboxylic acid derivatives because they have that really good leaving group. And so then in the second step, these are the conditions to take an acid chloride and make an amide. So we have two equivalents of the amine in there because we need a second equivalent to react with the HCl that is generated. So when you react this with two equivalents of this amine, what you end up with is the amide. So you have replaced that chlorine with a bond to one of those nitrogens, or one of those amines, I should say. And so you'll have one hydrogen left over and CH2, CH3. So that's the major organic product. But if you're curious about the second equivalent of that amine, its role is to react with the HCl that's generated. So after you have attacked and kicked off the chlorine, that's where your chloride comes from, and notice that you had two hydrogens on your amine. Well, after that nitrogen is bound to the carbonyl carbon, then it would have a positive charge, and so that's when the second equivalent amine will come and take that extra proton. So this is the answer that we see here in C.